Welcome back. I hope you enjoyed working on the project from our previous lecture. In this tutorial, we will perform an FFT analysis on the current waveform of a half-wave diode rectifier. Problem statement: simulate a half-wave diode rectifier circuit and perform the following tasks. 1. Use the Fourier block to determine the magnitude and phase angle of the fundamental frequency and the first two harmonic components of the current waveform. 2. Use the following two methods to obtain the harmonic spectrum of the current waveform and calculate the total harmonic distortion value. 1. Write a MATLAB script using the harmonic magnitudes obtained from the Fourier block to generate the harmonic spectrum and calculate the total harmonic distortion. 2. Use the Fourier analysis tool available in the Power GUI block to obtain the harmonic spectrum and THD directly. Getting started. So, let's get started. Launch Simulink and open the model we simulated in Lecture 2. Add the required blocks. Go to the Simulation tab and open the Simulink library browser. Type Fourier in the search bar and press Enter. Right-click on the Fourier block and select Add Block to Model. Also, add a display block to the model. Now, type THD in the search bar. Press Enter and add the block to your workspace. Arrange the blocks. Rotate the Fourier block and connect its input to the output of the current measurement block. Connect a display at each output of the Fourier block. Let's rename the display blocks. Also, connect the THD block at the output of the current measurement block. To find the THD in percentage, we need to connect the output of the THD block by a gain block. Let's add a gain block. Also, add a display block. You can find the full course link in the video description. Go to the Live Editor tab and click Run. Here's the bar graph, showing the harmonic spectrum of the current waveform. Since the value of the third harmonic is very low, it may not appear on the graph. You can zoom in to view it. Double-click inside the graph. And then click the zoom in icon. reconstructing the current waveform. Now, let's retrieve the original current waveform from its harmonics. Go to the Simulink library and add a sine wave block. Also, add a summation block from the Math Operations section. Add a scope to the model. Let's connect the blocks. Open the sine wave block. Enter the magnitudes of the fundamental, second, and third harmonics. For the bias, enter the DC value only in the fundamental component, and set it to 0 for the others. Enter the frequencies of the three components. We have 1, 2, and 3 as the harmonic numbers. Multiply each by 2 pi, then multiply by 50. To get the frequency in radians per second. Enter the phase values in radians. Multiply the phase values by pi over 180. Click OK. Let's simulate the system to observe the result. Open the scope to view the waveform. This waveform is similar to the current waveform of a half-wave rectifier. Let's compare both waveforms. You can retrieve a more accurate waveform by adding more harmonic components. The sine wave block generates all the components. The summation block adds them to reconstruct the current waveform. You can find the full course link in the video description.